we're going to be looking at functions and their specific notation. We've dealt with functions before, so this should be a quick review. With a function, we have independent variables, dependent variables, and technically any set of ordered pairs or relation. So remember that an independent variable this variable is not affected by anything else. So for instance, time. Time is going to keep going on and on and on forever, regardless of what happens. It doesn't matter if, you know, if the world happened to stop, time would still keep going on. Dependent. So this could change depending on your independent variable. This is generally your y value, your independent variables are your x values. So for instance, hours, that's time per, if I get paid dollars per hour, the dollars are dependent upon the number of hours that I work. So our hours, aka is time, is going to be our independent variable, and our dependent variable is our dollars, because we need to know how many hours we worked in order to get paid properly. Now remember that a function is where you have your x values with no repeats. So every x value is paired with exactly one y. No repeats in the domain, if you remember correctly. Okay, so when I'm looking at this, let's say that I have my domain. Actually, not my domain. Let's go with a set. I've got 1, 2, 2, -3, -2, -1, -4, 2. All right, so I'm basically looking for my domain. My domain are my x values, remember? And I've got 1, 2, -2, -4. Do I have any repeats of that? No, I've got 4 points. So this checks out in that it is a function. So what happens if you don't have, you know, a set of ordered pairs? Then you have a graph. Well, you have to look at the graph and determine whether it is a function. And remember, that is based on our vertical line test. Okay, this is easier if I just explain it than try to give you a definition with an example. Okay, so if I were to have my graph of this, what the vertical line test does is you can stick a vertical line wherever you would like. So notice I've put them in multiple spots. If your graph touches that vertical line more than once, it is not a function. So if I look at this first on the left vertical line, it touches the graph once, we're good. 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 If I were to keep putting vertical lines, would the graph always just touch that vertical line once? In this case, yes. So this is a function. After you've established that you have a function, now you need to go into actual function notation and look at how to evaluate a function. when you're looking at this, it's going to be in what is called Euler's notation. I don't ever refer to it that way. I always have it as function notation. I'm sorry, I just call it that way. But technically it is Euler's notation is another name for it. So let's say that f of x equals 3x squared plus 4x. And we want to find out f of negative 2. So what this means is that I'm going to take that negative 2 and I'm going to plug it into my x spots. Okay? When you look at this, a lot of people, I put a negative for a reason. A lot of people, they'll plug the number in, which is great, and then they'll try to do it in their head, or they'll type it right in their calculator and they'll forget the parentheses. And what happens, remember, is when you have a negative times a negative, it becomes a positive. If you don't put those parentheses around this middle term of that negative 2 squared, your calculator is going to make it a negative 4. Remember, whenever you have a negative and you're trying to square it, always put it in parentheses. Anyway, sorry, just my little rant there. F of negative 2 equals, in this case, we've got 3 times 4 plus negative 8. So we've got 12 minus 8, which would give us a 4. So f of negative 2 equals 4. That's function notation. All you're doing is evaluating. So what you're doing here, you're finding the domain, you're finding your range, you're finding function notation, and you're determining whether or not you have a function based on the vertical line test.